matter doesn't always stay in the state that it is in originally, and so we call that changes in state. So this is when you change from one state of matter to another. So for example, here in this picture of Mount Rushmore, this beginning picture, there's no clouds. However, 3 hours later, we start to see clouds developing. So what caused the clouds to form? And that would be what we call condensation. And that would be a change in state from a gas into a liquid. And so the gas particles or the water vapor in the atmosphere cools down and condenses to form liquid water. And that's what clouds are made of. So this is a physical change in matter because regardless, it's still, the material maintains its identity. So when the water vapor turned into a cloud, it's still water. And these changes are reversible. So this diagram shows you if you start with a liquid and you go to a solid, we call that freezing. Vice versa, start with the solid, go back to the liquid, and we have melting. And so you can see that there's a bunch of different, 6 different phase changes. We call them phase changes as well, that we're going to take a look at. So energy, remember, always is involved. So the only way to go from liquid water to solid water or solid water to liquid water is with the presence of energy. So energy is either gained or lost. So when matter changes from a liquid to a solid, it will lose energy. And the opposite happens when a solid changes to a liquid. It would gain energy. And so a lot of this has to do with temperature. And so remember, temperature is the average kinetic energy of the particles of matter. So remember, we have our liquid particles, and they're kind of all over the place. And then when it turns to a solid, those particles slow down and become much more orderly. And so going from high energy to low energy. The reverse is true when you go from a solid. We have low energy, and then if it melts, we get a liquid, and so that will go to high energy. So changing between liquids and solids, we have freezing and melting. Freezing is the process in which a liquid changes into a solid, and so when the liquid cools, those particles lose energy, and there's not enough energy to slide past each other anymore, so they slowly get locked into a fixed position. The freezing point is the temperature at which a liquid turns into a solid. So we indicate freezing point by a capital F, and we call this a subscript P, freezing point. So in degrees Celsius, our freezing point of water is 0. The freezing point of iron is 1,535 degrees Celsius, and the freezing point of oxygen is negative 219 degrees Celsius. So you can see that each substance has its own unique freezing point. So then melting is the reverse process in which a solid changes to a liquid. In this process, energy is gained. This allows the particles to overcome some of the forces of attraction that holds them together, and they're able to slip out of that fixed position of a solid. So the melting point is the temperature at which a solid changes to a liquid. And the melting point is actually also the freezing point. The only difference here is it matters if the temperature is increasing or decreasing. If the temperature is increasing, we have melting. If it's decreasing, we have freezing. So when we have we have two phase changes between liquids and gases, we can have condensation and vaporization. So vaporization is the process in which a liquid boils and changes to a gas. The particles of the liquid energy, they gain energy to completely overcome the force of attraction between them, and this allows them to change to the gaseous state. So we call this the boiling point, the temperature at which a liquid boils. The boiling point of water, we should know, is 100 degrees Celsius. In Fahrenheit, it's 212 degrees. Other types have different boiling points, just like they had different melting or freezing points. Your table salt will boil at 1,413 degrees Celsius, and nitrogen boils at negative 196 degrees Celsius. So each of these boiling points, freezing points, melting points, they're all ways for us to help us identify an unknown substance as well. So evaporation is a process in which a liquid changes into a gas, and this happens when there is no boiling taking place. And so this occurs when particles at the surface of a liquid absorb just enough energy to pull away from the liquid, and it allows them to escape into the air. This happens faster at higher temperatures. So the important thing to notice here is that this occurs at the surface of a liquid. So the water molecules in the middle of this pond, deep down, 2 feet under, are not going to evaporate. Only the water molecules that you can actually see at the surface are going to evaporate. So then we have condensation, and this is a process in which a gas changes into a liquid. So example, fog on the mirror in the bathroom that forms during a shower is condensation. The water vapor from the hot shower will cool and then turn to liquid on that bathroom mirror. And so the cooler water particles no longer have enough energy to overcome the force of attraction between them, and the particles come together and form droplets of liquid. So we also see this on cool spring mornings. The water vapor in the air condenses on the cool blades of grass, forming dewdrops. When a glass of ice water sweats on a warm day, some of that water is evaporating into the air and then cools down and then will condense on that glass. And then we have changes between solids and solids and gases. Sorry, this one's probably a little less well known, but we call it sublimation, and this is when a solid will change directly to a gas without going in the liquid state. And so the particles of the solid absorb enough energy to completely overcome the force of attraction between them. So this is what happens with dry ice. This is solid carbon dioxide that absorbs enough energy very quickly to go directly to a gas. Sometimes we have snow that will sublimate, and this often happens on a sunny winter day when the air is very dry, but it will go from the solid snow directly to a gas. And then lastly, we have deposition. And this is a process in which a gas changes directly to a solid, again with skipping the liquid state. The gas particles become very, very cold and they slow down very, very quickly. And this happens when water vapor in the air comes into contact with a very, very cold window pane. We see this in Minnesota a lot when our windows get icy because it's so cold outside. The water vapor may change to tiny ice crystals on the glass. And so those are your phase changes. And The last thing that I want to talk about with these phase changes is what it looks like on a graph. So when we have a phase change, let's say we'll have temperature along the x-axis, and then let's go time. And then we'll do temperature on the y-axis. And so what generally happens as time starts, we can either increase the temperature or we can decrease it. So in this particular case, we're going to increase the temperature. When a phase change happens, the temperature stays the same. And so that gets indicated by a horizontal line. And then it's up to us to use the other data given to us to determine what type of phase change we're experiencing. And so from there, the phase change could be done, or the temperature could continue to climb, and we could see a second phase change. So we'll label that one in orange. So a couple things that you need to pay attention to when you look at these phase changes is, firstly, is energy. Is it going up or increasing or decreasing? So in our particular example, you can see that the overall trend as time goes on is that our temperature is going up. So we have an increasing temperature in this particular example. Then you need to take note of phase changes. And so in this particular case, we have a phase change here and a phase change here, indicated by the horizontal lines. And so in this case, we have two phase changes. And so remember, during a phase change, there is no temperature change. And that gets indicated by a horizontal line. So then our next task is to determine the states of matter at each section of the graph. So basically what we need to do here is that every time we have a change in direction, we need to draw a vertical line. Doing this gives us 1, 2, 3, 4 sections of the graph. And now in each of these sections, we need to label the state of matter present. And so in this first state of matter, or in this first section, we know we're heating something up. And so we can heat solids, we can heat liquids, we can heat gases. And so generally, when you have two phase changes and you're heating, so the stipulations are two phase changes, you're adding energy or heating up, then the starting state is a solid. So here we have a solid, and that solid is warming up. In section 2, we have a phase change. So our solid is turning into something. And so logically, usually it goes solid to a liquid. We won't deal with any phase change graphs that deal with deposition or sublimation. So then in phase 3, we are left with the end product of the second section, so a liquid. And then lastly, in our 4th stage, we have to start with what we have in stage 3. And so we start with our liquid, and our liquid is going through a phase change. And so the only one that makes sense for adding energy is turning that liquid into a gas. And so these graphs, very important that you can identify whether energy is being added or taken away. You need to be able to identify where on the graph there are phase changes. And then lastly, you need to be able to identify the states of matter at each section. And when there is a phase change, what is that phase change?